Alright guys, so in the Northeast today there is going to be a severe weather event. So you can see up here, pretty much this corridor that's kind of just like northwest of the I-95 corridor. And the main threat is basically going to be wind, but there is tornado threat, especially in the northern ends of that slight risk. And there's some hail threat with any potential supercells that form. So let's break this down. So where are these storms coming from? So first off, if we look right over here, this is the 500 millibar vorticity, so it can tell you kind of where there are kinks in like the upper level jet, because vorticity tells you how much the air wants to spin. So where the air is going to be curving, it's going to want to spin. So up here in Michigan, we can see this area of vorticity maximum that moves into Quebec. So this is the short wave that's going to be triggering all of the storms down here. Now, how is that going to work? Is that this short wave is going to trigger upper level rising motion and kind of have like a forcing factor for this cold front that's already set up down here to move to the west and trigger storms as it moves to the west. So this cold front that I'm talking about right now is set up, at least as of 9Z this morning, it's set up kind of central Pennsylvania up through upstate New York. And this is the cold front that's going to move through and trigger the storms. So the short wave is kind of like the upper level forcing mechanism, whereas the cold front is the direct forcing mechanism for these storms. Now, let's take a look at what these storms are going to basically look like. So I've just pulled up the HRRR model. It's a 12Z run today. And what's going to happen is that into midday, the northern area of this, pretty much like north of NYC into like actually like Ulster County, Greene counties, New York, northwards and westwards, eastwards, we're going to get kind of a line that forms. And this line of more organized storms is likely going to have supercells embedded in it, and especially supercellular development initially before it congeals into a line. So this is what I would say is the main threat area where all three hazards of wind, hail, and tornadoes are possible. Now further south, right, NYC and south, we're going to have this initial cold front, right? It's going to be kind of more diffuse, right? Like if we want to look at what the front is doing at this time, let's pull up the theta E and wind barbs. You can see there's a really sharp transition over here, but further south, it's kind of a lot more diffuse because this cold front's not as strong. And what that's going to result in is more of a cellular storm mode. So let's take this back to the loop, and you can see that kind of cellular storm mode. The first time that storms are going to fire is going to be initially when the supposed front would be moving through, and we see some development start, and then later there's going to be more cellular development. So in this case, as you'll see later more like why this is the case, the tornado threat is going to be a little bit lower here. It's going to be maximized in like northern Jersey into NYC areas, but it's not going to be anywhere near that of further north into like southeast New Hampshire and southwest Maine. So in this cellular storm mode, there could be some marginally weak supercells, but they're not going to have as much of a tornado threat. So let's look at why this is the case. So if we want to look at the upper level winds, right? First, we want instability. Actually, let's look at the instability. So instability is the first ingredient you have for thunderstorms. So if this would actually load up, I'd be, yeah, here we go. So let's look at how the instability develops into midday. So we can see there's a good amount of instability pretty much everywhere around 1 p.m. Eastern. And if we want to look at the absolute max, we can say that like the best moisture quality is in this eastern Pennsylvania, New Jersey area. But that instability basically wanes into the evening and as the cold front is moving through, right? Now let's look at the winds, right? Because the wind shear is the other big thing. So upper level winds are going to be pretty much similar everywhere. The 500 millibar winds are going to be similar, maybe a little bit stronger into the Maine, New Hampshire area. But the really important thing that I want to show you is the lower level winds, the lower level jet that forms throughout the day. This is at 850 millibar, which is about 1 kilometer up in the atmosphere. So again, if this would load, I'd be able to show it to you, but it does not want to load. Here we go. All right. So this jet that forms throughout the day, into the midday, into the evening, it's maximized in the classic northeast area, right? Like Maine, New Hampshire, Massachusetts. It's maximized out here, whereas it kind of continues a bit into northern Jersey and then wanes significantly. So that means that the potential for rotation near the surface, which is needed for these strong supercells and tornadoes, is going to be lacking. It's going to be lackluster south of northern Jersey, meaning that that's not where the main tornado threat is. So let's just take a look at how these storms are going to be influenced by their environment. So let's take like a sounding, let's say up here in New Hampshire. So ignore the thermodynamics on the HRRR. It's not the best of them. You can see that it doesn't really get the moisture right, at least in my opinion. This photograph is more kind of with a right angle past 1 kilometer. So that means that there's good potential for rotation in the lower levels of the atmosphere. Whereas we take one down further south, maybe around where I am, there's no kind of curve that makes it a right angle. It just very weak winds up to 1 kilometer, then it increases a bit more. So the potential for rotation is less. And just for one last thing, let's take a look at the RRFS model, which is the kind of experimental model, which is going to be replacing the HRRR as soon as it becomes operational. I feel like this has a way better handle on moisture and things like that than the HRRR. So this kind of perfectly illustrates the idea of a line moving through the northeast, New England area, and then more cellular storm mode into like the NYC, NJ, eastern Pennsylvania area, because of the fact that that lower level jet up here is forcing the storms much better, getting them much more organized and giving the potential for rotation as well, whereas further south, that low level forcing is nebulous, so it's just more of a cellular storm mode. So just for one last thing, let's look at the updraft helicity tracks, which tell you kind of where the maximum rotation is going to be. All right, the RFS is probably not the best model to look at this in. I would say the HRRR is a lot better for this. So let's take a look at that through about 2 a.m. So as you can see, there is potentially some transient supercells that could form in this eastern PA, New Jersey area because of the pretty decent instability. But the main rotation potential will be in New England. So I hope you guys learned something from this video, and definitely pay attention to the weather today so you don't get caught in any severe thunderstorms. And yeah, thank you.